Hello everyone. For this session, we're going to begin on the chapter on turning effect of forces. Now, before we go any further, let's get familiarized with some of the basic terminologies. Now, first of all, there's this word known as pivot. Some of you may know it as anchor, and some of you may come across this word called fulcrum. Well, they are the same meaning over here. They're just at a point whereby the mechanism will rotate. So it's either a point or an axis. Now, for these two diagrams, let's take a look at where the pivot is. Now, when you look at the laptop, there will be one position on the laptop where when you flip the screen open or close, there'll be that one position that doesn't move, and it's over here. The line which I had in red, this point here is known as the pivot. And for the door, it's almost the same thing. Along the hinge, where I highlight in red, pivot. Now, for these two examples, other than identifying the pivot, can you identify the force and the perpendicular distance? The perpendicular distance we're referring to is between the force and the pivot, point where the force is exerted. Now, let's come back to the laptop example again. Let me change the color. Now, when you flip the laptop open or close, where do you exert the force? We know that you don't exert the force here. You don't put a force here. That's quite absurd. We actually exert the force at the top of the screen, and it's usually around the point in the center, which I highlight in purple here. And this is where you exert the force to close the lid. So this is where the force is exerted. And the perpendicular distance is actually from the pivot to the force. The perpendicular distance is actually such that the force and the distance are perpendicular to each other. So that's for the example of the laptop. How about the door? Well, the door is a little bit more straightforward. When you want to pull the door, you pull along the handle, and the handle is always located at the other end where the hinge is, and I circled in purple. This is where you exert the force to open the door, and this is the perpendicular distance. So in order for you to understand how the object turns, there are three things that you need to identify. You must identify where the pivot is, you must identify where the force is, and you must identify where the perpendicular distance is. Now, if up to this point, you are still not able to identify how the force and the perpendicular distance factor into this turning effect, just continue to watch the video. As I illustrate with more examples, your idea should become clearer. What actually causes the object to turn in the first place? And that's why this chapter is called turning effect. What causes the object to turn? First of all, we must have a pivot to hold the structure at a one point so that a point remains fixed. And this example which I show you here is a spanner and a nut. It's a very common example, and it's something that's very common. Over here, the pivot is actually refers to the center of the nut, which is point I make here. Okay, let me change the color of the ink. Point I make here. This is the pivot, the center of the nut. Now, the center of the nut is the part where it stays stationary. So when I exert a force on the spanner, the pivot remains stationary. The rest of the structure actually turns about the pivot. Brings to the next point. So which brings to the next point. The other thing that is needed for turning effect to happen is actually the force. And the force has to be exerted some distance away from the pivot. And that's why you have this distance here. It has to be some distance away from the pivot. And this force will actually cause the structure to turn. So as long as I continue to exert this force, the structure will continue to turn. And when you look at the diagram, look at the distance and the force. And this is what I meant by the distance and the force have to be right angled to each other. Why this we coin this term called perpendicular distance. Right, we don't call it perpendicular force, we call it perpendicular distance. And hence, and that's how the turning effect comes about. We call it a moment of the force equals force times perpendicular distance from the pivot to the line of action of the force. It may sound like a mouthful. Perpendicular distance from the pivot to the line of action of a force. Let's look at this mouthful. Perpendicular distance, pivot to the force, and not only might we say the force, it's actually the line of action of the force. So what does this whole thing mean actually? Why is it such a mouthful in the first place? Let's continue. Right, we have this moment of force equals force times perpendicular distance from pivot to a line of action of force. In science, we try to keep things simple. We don't write so many things. And hence we have this. M equals F times perpendicular D. So it means F, it means force, and the SI unit is newtons. Perpendicular distance refers to perpendicular distance from the pivot to the line of action of the force. And I emphasize again, line of action. Draw more into that later. And M represents moment of the force, and the SI unit is Newton meter. Some of the other common units used in moments is actually centimeter. Some of the other common units used. Okay. So when you're given centimeters, remember the focus is understanding the problem. So you can actually express your unit in Newton centimeters. If you're given Newton and meters, then express your unit as Newton meters. Otherwise, it's Newton centimeters. Okay, depending on the question. Very much depends on the question. So what are the kind of turning effect that we have? Now, in real life, turning effect can happen in all directions. All directions. But on paper, we try to keep it simple. So we represent it in either clockwise movement, as I represent in red here, clockwise movement. And I'll show you the face of the clock here, because the face of the clock is a very good way to illustrate the direction of turning effect. Pivot is at the center, and when we say clockwise movement, that means we follow the direction of the hands of the clock. If the turning effect turns this way, we call it clockwise movement. And if the turning effect goes the other way, opposite direction from the hand of the clock, this is known as anti-clockwise movement. I say again, so there's two directions we are concerned with at this point. There's a clockwise movement and anti-clockwise movement.